All right, so today we're going to be talking about some real world use cases on what makes reactive programming awesome. I've been working quite a bit with JavaScript, probably since before a lot of you were born. And since 2010, I've been working a lot through the industry on adopting reactive programming. So here we're going to cover exactly what we've been doing in places like Netflix, like Slack, Delve, and other particular companies out there. So let's just start off with a little bit of JavaScript, just to get people started. So. Anyways, I also like to talk about concurrency, and the best way to do it is through a joke. So take me down to the concurrency city where green pretty as grass, the code, the and are. Yeah. Sorry. Well, that's how I feel mostly about JavaScript and concurrency. So most of you people will know me through wearing this stupid little hat up here. And I like to call myself an open sourcerer just because at Microsoft that's exactly what I do, is I work on open source projects all day. And so you can find me here on the interwebs here, and I'm fairly unoriginal. And if you really know me, then you'll also know me as Lambda Calrissian, the original web rebel. So I work for a small company from a land far, far away. Called Microsoft, and I'd like to think, given my open source work and everything, all the advocacy that I do, is that I put a little bit of metal back into it. Anyways, so I've been particularly working on the reactive extensions for JavaScript probably since 2009, 2010, and I really do believe that I am an RX pusher. In the fact that we are trying to basically move this everywhere. So, okay, so how about the actual applicable usage of this? So, for example, Netflix is streaming movies to any device out there, and currently they're 1/3 of U.S. broadband traffic. That actually might be more nowadays. And what they had is that they had a problem that they had large asynchronous problems because of the fact that everything that they had to do on the web was asynchronous. And so how they did that, as well as Microsoft and Slack and others, thought just differently about events. So most of the things that we do in our apps are asynchronous, whether it's the app startup itself, so preloading any data to the player, to data access, to data animation, and even view model binding. But with that comes a number of problems, such as memory leaks, race conditions, callback hell, and that is a real thing, and I'll actually show you an example of that. Complex state machines and disjointed error handling. Where exactly do my errors go? I don't know. So we began this journey with Netflix, and it goes back a number of years. They were trying to create an app for Java using Java and Android, iOS, and Objective-C, .NET and Windows Phone, and on the web as well. The problem is that each one of those platforms had a different way about talking about asynchronous programming. So what they did is they decided that what they wanted to do was settle on a single way of expressing reactive programming or event-driven programming. And because of that, because of the factor of learning this single way about doing it, they were able to then take engineers who were doing Groovy work or doing JavaScript work and move them to Java because they're speaking the same kind of reactive, event-driven language. So going back a few years, they had a lot of problems with this because Java has a different way of describing it. You have closure, you have everything else. But to really get started, let's just outright admit it. Async is awful. We can't do multiple things at once very well. And we are living in callback hell, and it's not just, oh, I'm just chaining a bunch of functions together with callbacks and error handlers. It's the fact that we're dealing with these fairly complex state machines here. Where exactly do I handle all my errors? Where do I say the player is finished? All of those sorts of things are very, very difficult to kind of track, and that you kind of lose the linear style of thinking, and more along the lines of you're embedding your logic in all of these particular callbacks. So what you end up with is more like a cow than or howlin' coo, or whatever you want to call them here, and you end up with more of that. And even dealing with events is very, very difficult because, like I said, is you're dealing with the race conditions here of which one do you handle first and what state do you keep around. Well, what you end up with mostly is the fact that the stream is going and you don't know what to do until you've actually seen it go away. So promises really are part of a solution, but they're not the solution. So you can do the callback health kind of style here by initializing the movie, authorizing it, saying there's a login error, play the movie, and unauthorized. But there are a number of things right now with promises that aren't exactly promising. Well, for example, cancellation is not a thing yet. In the fact that they ship the fetch API without the ability to actually cancel it using a promise. So you'd say fetch.then, and you're like, cancel? Oh, shoot. So what you ended up with is a fairly large discussion here with 204 comments, 21 participants, so you could easily say how many engineers does it take to cancel a promise. So what they've done is introduce this third state, which may go somewhere, who knows, to be able to do finally cancellation. And the same thing applies to finalization, and the fact that if you're dealing with any resources, you want a way to finally clean up your resource when you're done. You don't have that in plain promises. So you end up with a problem in the fact that you're trying to do something to clean up after yourself. But now, luckily, they're working on promise.prototype.finally, and the cancellation thing from Dominic DeNicola also has said thing. But let's get practical here. How many people have implemented a type-ahead search? How many people have done it well? Good question. Okay, so let's go ahead and actually take a look at an implementation I did in pure jQuery. So it includes all of the debouncing, all of the retry logic that you might want to do, and so just to make sure that you can have XHRs and your key ups talk to each other. So it's write more, do less. But a question is, can we do better? And it became such a thing that our former president, John F. Kennedy, said we choose to solve asynchronous programming and other things not because they're easy, but because they're hard. And he later changed this to the moon because at least one was possible, I think. Anyways, so what do we do? So, thinking about this, about our problem with callback hell. How do we exactly solve this? So we can do the init as we had before, but instead of then, we have flat map, which is largely the same kind of thing, compose one with another. And we can also do things like retry 3 times, and then we can say take until cancel. So if I hit that cancel button, I'm like, no, I didn't mean that, then it cancels everything else out, and you end up with a nicely cleaned up solution. And even that mouse drag that I showed that was largely a page long, we now have something as small as this in order to actually move an image around. And even type ahead, that long page that we had before becomes about 5 or 6 lines in the fact that we can map to get the value, we can debounce so that they don't, when you're typing so fast, it doesn't really fire off to the server. And in fact, you can say it's only distinct values. So every time I hit them left arrow, right arrow, it doesn't fire. And then we can do switch map, which basically says anything that happens out of order gets canceled. So the next request comes out, the previous one gets canceled. Next one goes out, previous one gets canceled. So you never have that situation when you're typing and you get that wrong result because it finally came back afterwards. So it's much, much harder to burn yourself. So what is this reactive programming, that stuff that we actually heard about? Not this. Nope. So what is it really? Well, readily going to the dictionary is usually the first option that we would do, and it would say readily responsive to a stimulus. Okay, not really helpful, because we've been doing that forever, haven't we? And us hipsters who have dealt with Excel said, yes, you young kids, we've been doing this forever, and the fact that I can update one cell and two cells, and then automatically the chart updates without me having to do anything. But there is a paper out there if you're really, really interested. But I know how most people will react to something like this when handed an academic paper. Most of us have that same reaction, even the smartest of it. And for people like Robin, for example, we have a German word for exactly that. The fear of academic papers, I believe, something like that. Anyways, so what is reactive programming? I think it's a little bit more than that. I think it's react to load as well. When do you decide to start throwing data away? When do you decide to start shoving chocolates down your front of your shirt? It's a good question. In the same way that how do you decide that you're reacting to failure, whether you decide to jump out of a window or not? Or even react to users when you decide whether you're going to give them the beach ball of death. So back in 1994, what we had was this design patterns book. And in there, we had this idea of many different patterns and how they were connected, such as the iterator and observer. But they weren't connected. But we did. So what we're going to ask you is, what's the difference between an iterable and an event? And I would say nothing other than the fact that events are nothing more than collections over time. So when you have ES 2015 iterators, you also have the same kind of thing where as data moves through, you have a collection of data that comes through as well. But really, what we want is something like this, where we have a notion of a single hard class to represent event-based data, and we can have an observer where we register our handler to say, give us more data when we have time, and then we can have a subscription which basically controls when we want to listen or not listen. So it's different than the add remove listener in the fact that now the subscription itself is composable. So now we have a first class value where you can pass it in or you can return it, which is really great for testing. Now, where does it fit? Well, if you look at it, object for a single value synchronous and promise for a single value asynchronous, we have the iterable already, so we can do using arrays to do iterable synchronous, but we also have the observables, and it's largely the same code. So you get that Zen-like feeling that everything that you're doing is a stream. So you can write a lot of these applications using map, which is taking one value, projecting it to another. Filter, to only say what you want from a collection. And flat map. So flat map is kind of like, it's like the map and then flatten for this particular class. And in fact, ES 2018 or something like that is looking to add that to array. So it's really kind of cool as to how to combine two different sequences together. So no matter what you do, you should probably just flat map it. So the future really is here, and the fact that, so for example, Google, of all places, took a really big bet on observables and reactive programming, and the fact that their HTTP module is now based entirely on observables and a few other things. So going back to our type ahead, we have this idea of form controls and so forth and async pipes, but I think what's really kind of cool here is the fact that now the JSON-P from the HTTP service is now an observable, and the fact that now I can say .get and .map, and now I can do that same type ahead that I did before, but instead of using this from event, we say this.term.value changes. So really, this observable is really at the core of what it is all about. And even for really hard problems, such as Netflix polling, so when you're trying to keep only what you want in view, how do you do that? Well, there's code to do exactly that. And I'm not, given this is a 20-minute talk, I can't walk you through all of it, but suffice it to say, is it's going to, what I really want to show you is the fact that it's going to say, row down here at the bottom is row.getData.take until row hides. So you're going to continuously get the row data until it hides, and then it's going to completely get rid of all of that stuff that you had before. And even the Netflix player here that we had before gets transformed in the fact that we can do the stuff that we've already shown you here. Now, implementing this in spell check and Slack is also one of those hard problems. And like I said, the code is fairly dense here. But what they're able to do is when you're finally stopping typing for a little bit, what you'll be able to do is determine the language, and B, determine whether you misspelled something. So for example, if I'm typing TEH and it goes, no, what you mean is THE, it will automatically correct it for you. And what does that is thinking differently about events and timeouts and so forth and composing it all together. So if you're using things like Redux and so forth, you can actually replace Redux with just one line of observable using scan. And if you want to talk about that, I'd be more than happy to afterwards. But we have this idea that we can also do this in Node as well as the browser. And what we're doing is we're trying to bring this also to ECMAScript in the future. We're still kind of on stage 1, but it's really what we're trying to do is trying to make reactive programming amazing again. And so with that, I would like for all of us to make reactive programming great again. And we're going to build a wall around all of the non-reactive frameworks. And I'm pretty sure we can get ScotlandJS to pay for it. Thank you.